Today, we're going to talk about the invisible magic that powers pretty much our entire modern wireless world. It's this incredibly clever technique that lets us cram a mind-boggling amount of data into the airwaves.
I mean, it's the question we're all asking, right? We want more from our wireless connections every single day. For streaming, for gaming, for work, for everything. So how in the world do engineers keep up? How do they keep squeezing more and more performance out of the same limited airwaves?
Well, the answer isn't just about building bigger antennas or blasting out more power. Nope, it's about working smarter, not harder. And one of the smartest tricks in the book is a technique called OFDM. And that's exactly what we're going to break down right now.
Okay, so what is this thing? Let's get right into it.
That's a mouthful, I know. Orthogonal frequency division multiplexing. But at its heart, it's a way of sending digital information. The really key thing here is that it doesn't use just one big signal. Instead, it splits the data up across lots and lots of smaller signals, and it sends them all at the exact same time. You can think of it like turning one giant, slow data highway into hundreds of smaller, faster parallel lanes.
Now, to really get why OFDM is so brilliant, we actually have to take a quick look back at how things used to be done, and you'll see it's a classic story of wasted potential.
So, why did we even need a new method? I mean, what was so wrong with the old way of sending a bunch of signals through the air?
So, the earlier technique was called frequency division multiplexing, or FDM. And the logic was pretty simple, right? If you've got multiple signals, you just keep them separate. You put them in their own little frequency lanes to make sure they don't bump into each other and cause a big mess of interference.
But here's the problem with that approach. To keep those signals safely apart, you had to leave empty space between them. These empty buffers were called guard bands. It's literally like leaving an entire empty lane between every single car on the highway. I mean, sure, it's safe, but it is an incredible waste of space. And in the world of wireless signals, that space, that bandwidth, is absolutely everything.
And this brings us right to the biggest, most important advantage of OFDM. It's all about taking back all of that wasted space.
This picture just shows the problem perfectly. Take a look at the top half. That's the old way, FDM. See those big gaps between each of the colored signals? That is pure wasted bandwidth. That's potential speed, potential data, just being thrown away to play it safe.
Okay, now look at the bottom half. That's OFDM. This is the fix. OFDM just gets rid of those empty guard bands completely. It shoves all the signals right up against each other, even lets them overlap so that every last bit of available space is being used. This is its main advantage, just raw efficiency.
So here's the big takeaway. OFDM gives us something called spectral efficiency, and it is a game changer. By getting rid of those wasteful guard bands, we can pack way more data into the exact same channel. And that translates directly into the faster speeds and the rock-solid connections that we get from stuff like Wi-Fi and 5G.
But hang on a second. If all the signals are overlapping, shouldn't they just crash into each other and create a garbled, useless mess? Well, this is where the real magic happens. And that really is the million-dollar question, isn't it? How can you have all this overlap without total chaos? It kind of seems like it should be impossible, but the answer is hidden in some very clever math. The secret ingredient is a property called orthogonality. Now, I know it sounds super complicated, but the idea behind it is actually beautiful and simple. It just means that all these signals, all these frequencies are designed in a special way so they can exist right on top of each other but act independently. They're mathematically engineered to basically be invisible to one another at just the right moment.
So check this out. Here's how it actually works. A receiver, say in your phone, reads the data from a signal right when that signal's wave is at its absolute peak. So when this blue signal hits its highest point, that's the exact moment the receiver is listening to what it has to say.
And here is the genius part. At the precise instant that the blue signal is peaking, the math of orthogonality guarantees that all the other signals overlapping it, like the pink and yellow ones here, are crossing the 0 point. They have a value of nothing. So when the receiver is listening for blue, all the other signals are effectively silent.
And this unique trick, this orthogonal feature, means the receiver can look at this big, jumbled, overlapping wave and still perfectly pick out each of the original signals one by one with zero interference. It's kind of like being able to listen to just one person talking in a super crowded room because everyone else magically goes silent for the split second you're listening to them.
So what's the bottom line here?
The big advantage of OFDM isn't just about squishing signals closer together. It's about a total breakthrough in how signals are designed. By creating these special waves that can perfectly ignore each other at the most critical moment, engineers unlocked a level of efficiency that nobody thought was possible. And that efficiency is exactly why we can get so much more data, so much more reliably, straight out of thin air.